Section 6.8, we're going to think about applications of quadratic equations. So if we look at something like the square of a number is equal to 20 more than the number, what could the number be? We notice that we're going to be looking at fairly basic steps for any application question. We're going to first read carefully, then we're going to identify the unknown or unknowns. In the case of quadratic equations, we're just going to have one variable. We're going to translate to algebra, solve, and check. So we notice if we're saying the square of a number is equal to 20 more than the number, we're going to start by saying x squared equals x plus 20. And so we now know that x squared minus x minus 20 is equal to 0. We can subtract x from and subtract 20 from both sides. So now we know that we're going to get x minus 5, x plus 4 equal to 0, and so then we can set that equal to 0. And so that one's being pretty straightforward. We're going to get x minus 5 equals 0, or x plus 4 equals 0, and so x equals 5, or x equals negative 4. And we're going to quite often get two possible solutions. We'll notice that depending on what we're doing, some applications a negative answer might not make sense. So we notice that if we were going to try to do area question, another common place for this is area of a rectangle. If we said something like the width of a rectangular painting is 2 inches less than the length, the width of a rectangle is 2 inches less than the length, and we know that the area is 120 square inches. We could ask, what are the dimensions of the painting? So again, we notice that we're saying W equals L minus 2. We're saying the width is 2 inches less than the length. And we also know that the area is 120 square inches, so we know that W times L has to be 120. And so we can combine that. We know W is L minus 2. So we now know L, the quantity L minus 2 times the quantity L has to be 120. And so we get L squared minus 2L equals 120. And so we can subtract 120 from both sides. We get L squared minus 2L minus 120 equals 0. And now we can factor. We notice that's going to be L minus 12. The quantity L minus 12 times quantity L plus 10 equals 0. And we'll notice that for the moment, for chapter 6, we're always going to be able to do that with factoring. We'll have other techniques we're going to learn in chapter 7. So we notice we find out that by that zero product property, we know L minus 12 equals 0 or L plus 10 equals 0. and so we know L equals 12 or L equals negative 10, but we notice this is the area of a painting, and so we notice we're saying that the length could be 12 inches or negative 10 inches, and so we notice that for a lot of application questions we discard negative values. So not all applications will discard negative values, but many will. We notice we don't want the painting to be negative 10 inches wide, or negative 10 inches long. And we notice we can go back, we said the width was L minus 2, and so we now know the length is 12 inches, and so the width has to be 12 minus 2 inches, and so that means that the width is 10 inches. And we can verify. We notice that 12 inches times 10 inches gives us that 120 square inches we were looking for. Oddly enough, we can also do this with triangles. We notice that because we know the area of a triangle is 1/2 base times height, we notice that if we were told that the base of a triangle is 2 inches less than 4 times the height, the base of a triangle is 2 feet less than 4 times the height. And we also know that the area is 6 square feet. We can ask what, this is actually an interesting case, we can ask what is the height and base of the triangle. We could be asked either of those individually. We could be asked what's the height of the triangle, what's the base of the triangle, and you notice that we pretty much have to find out both in order to get the answer regardless. So we notice that we're starting with area is 1/2 base times height, and we know that has to equal 6 square feet. We also know that that base is 2 feet less than 4 times the height, so we're saying 4h minus 2. So you have to be careful to take that 4h minus the 2 because we're saying 2 feet less than, so we don't want to take 2 minus 4h. That would cause complications. So now we're combining those two equations. We know that b equals 4h minus 2, so we know that 1/2 of the quantity 4h minus 2 times h has to equal 6, and so as we saw back in the last section, we have to watch that we are going to take half that gives us 2h minus 1 times the quantity h equals 6, and so we're going to get 2h squared minus h equals 6. We can subtract 6 from both sides, and we get 2h squared minus h minus 6 equals 0. And now we have to be careful to use that AC method. We notice we're going to take 2 times negative 6 is negative 12. Negative 1 is going to be negative 4 times 1 is, negative 4 times 3 is negative 12. And negative 4 plus 3 is negative 1. And so we can use factoring by grouping. We get 2h squared, h squared, minus 4h plus 3h minus 6 equals 0. Factor out a 2h. Factor out a 3. That leaves us with a common linear factor of h minus 2. And so we get the quantity 2h plus 3 times the quantity h minus 2 equals 0. And so we find out that 2h plus 3 equals 0 or h minus 2 equals 0. We could possibly discard that first one just because we know we're going to get 2h equals negative 3, and so we know h is going to turn out to be negative. But we'll just finish it off just to see what it gives us. We get h equals negative 3 halves, and the other version we get plus 2. We get the height is 2 feet. And so if the height is 2 feet, we can go back and find out that we said the base was equal to 4h minus 2. So we know the base has to be 4 times 2 minus 2. Gives us 8 minus 2 is going to be 6 feet. And if we want to verify, we notice that if we take 1/2 times 2 feet times 6 feet, that does indeed give us 6 feet squared. So we notice that gives us the correct area. So we get h is 2 feet, the base is 6 feet. So one classic is actually equations of motion. We notice that an object thrown into the air has position given by h. The height of the object is going to be given by its initial position plus its initial velocity times time plus 1/2 times the acceleration of gravity times time squared. And so we notice that if we were told that h, the height of some object, is negative 16t squared plus 256, this basically represents dropping a stone, the position of the stone. This represents the position of an object. Dropped off of a 256-foot cliff. Because we know the acceleration of gravity, so g in this case is equal to 32 feet per second squared. So we don't actually need to know that for our purposes for this class, but we notice that, we should say negative 32 feet per second squared, and so that's going to give us the 1/2 gravity, gives us negative 16t squared. And so we might ask, when will the object hit the ground? And so we notice that we can say the hitting the ground represents a height of 0. So we could say 0 equals negative 16t squared plus 256. We can divide both sides by negative 16. This is going to give us 0 equals t squared minus 16. And so we notice this is convenient because we can say t minus 4, t plus 4 equals 0. And so we're going to get t equals 4 or negative 4. And so we know that the object hits the ground at t equals 4 seconds. We should have specified that time was given in seconds. Yeah, so t is in seconds. And we notice that, again, we typically discard negative values. We aren't interested in the object hitting the ground 4 seconds before we dropped it. And then you'll also occasionally see more complicated things. We notice that if we said something like a rocket is launched into the air, with a vertical velocity of 64 feet per second, and gravity is once again, the acceleration of gravity is again negative 32 feet per second squared. One of the classic questions, what feet per second squared? One of the classic questions is, when will the rocket land? And we notice that, again, if you get a question like this on an exam, you're going to have the formula given to you. You'll be told h equals negative 16t squared plus 64t. What you need to know is that when we land, we can translate as negative 16t squared plus 64t equals 0. So we know it's going to land when the height is 0. And then we can also make more complicated questions. We could ask, when will the height be 4? When will the height be 12? When will the height be 100? But that gets into more complicated territory that we'll talk about more in Chapter 7, if we talk about it at all. We only have so many things we can talk about, so that may actually be something from Chapters 8 or 9, which are optional. So we notice we're solving this equation. We can factor out negative 16. It leaves behind, actually, it leaves behind t squared minus 4t equals 0. So we have to be careful that when we factor out the negative 16, we factor it from the negative 16t squared and from the 64t, which leaves behind a negative 4t. We notice we could also pull out a t. This is one of those cases where we can do the factorization in 2 steps. So we get negative 16t times the quantity t minus 4, and so either negative 16t equals 0 or t minus 4 equals 0. And so we notice that either t is 0, so basically when we launch the rocket, or t equals 4. And so we notice that the rocket lands at t equals 4 seconds. And you'll notice that we're always, for most of these kinds of questions, we ignore wind resistance and other factors. One other spot we'll use this is Pythagorean theorem. We'll call it Pythagorean theorem. Tells us that for a right triangle, with the right angle formed by sides A and B, the hypotenuse must have length C given by a squared plus b squared equal to c squared. So usually, if we have a right triangle with side lengths a and b, and c, we know a squared plus b squared has to equal c squared. So why might this be interesting? We noticed that if we were told that we had something easy, so if we knew that A was equal to 3 meters and C was equal to 5 meters, we can determine B. What is B? And we notice if we take 3 squared plus B squared equal to 5 squared, we notice this ends up being a really easy one, because we can say 9 plus B squared equals 25, subtract 25, make sure it's an actual 5 and not a squiggle, subtract 25 from both sides, we wind up getting B squared minus 16 equals 0, so we get B minus 4 times the quantity B plus 4 equals 0, and so we get B is 4 or negative 4. And you realize the answer won't always be 4, it just so happens that answers involving 4s wind up being not too small, not too big, so 4 winds up showing up more often than it possibly should. And so we notice, again, because we want to keep things positive, we'll just say B has to be 4, because we don't want a triangle with a negative side length. So again, we'll often disregard negative values. So if we wanted to look at something a little different with a triangle, we could imagine 2 cars leave the same point one traveling north at 12 miles per hour, the other traveling east oops 1L. At 10 miles per hour, we could ask, how far apart will they be after 4 hours? And so we notice that we're looking at, it never hurts to draw a picture, and not necessarily drawn to scale. We notice we're saying 4 hours times 12 miles per hour versus 4 hours times 10 miles per hour. And so we notice our 2 side lengths are going to be 48 and 40. And so we notice the distance between the cars is going to be given by the hypotenuse C. And so this is actually a pretty common structure. And so we're going to notice that 48 squared plus 40 squared is going to have to equal C squared. And so we notice that if we square 48, we're going to get 2404. Oh no, wait. 2500, 2304. Let's double check that. 1600 plus 640 is 2240, plus 64 is 2304, plus 1600 equals C squared, and so we know we're going to get 3904 equals C squared. And so at that point we'd probably use a calculator. If we wanted to do things the hard way, we could look at C squared equals 2 times 1952, which is then 2 times 2 times 876. 16, no it isn't, 976. Then that's going to be 2 times 2 times 2 times 483. Nope. 450 plus 38 is 48. So that's actually interesting because we know 48 is going to be, oh, nope. We can pull 4 out. So we get 2, actually we're going to end up getting 2 times 2 times 2 times 2 times 2 times 72. No, it isn't. $122. That's better. So we can pull one more 2 out. We're going to wind up getting 2 times 2 times 2 times 2 times 2 times 2 times 61. And so we know that C is going to end up being 8 square root of 61. And so we know that'll be not a little bit less than 64. Because we know square root of 61 is between 7 and 8. And closer to 8 than 7. So one more we'll see once in a while is we could see a triangle where we have the side lengths given by a variable. If we said something like one side was x, the other side was x plus 1, and the third side was 5, we notice that we can solve for x. We're going to say x squared plus that x plus 1, quantity squared, has to be 5 squared, and so we're going to get x squared plus 2x plus 1 equals 25, and so we get 2x squared, whoops, we can subtract 25 from both sides. We get 2x squared plus 2x minus 24 equals 0. We can make our lives a little bit easier by dividing both sides by 2. So we now know that x squared plus x minus 12 equals 0. And so we're going to get x plus 4, x minus 3 equals 0. And so we're going to get x plus 4 equals 0, or x minus 3 equals 0. And so x is negative 4, or x equals 3. And again, we'll discard the negative value, and so we know x equals 3, and the other side length has to be 4. Whoops. So side lengths are 3 and